So we're just going to go through solving these absolute values just for the review. So let's just go through. All right, so we have negative 10 minus 9 plus r minus 5 is equal to negative 105. Okay, you always, when you're solving, you always undo your addition and subtraction first. It's always reverse order of operations. So I'm going to add 5 to each side. So I have negative 10. Now this is multiplication, so remember that's multiplication. Negative 9 plus r is equal to negative 100. I divide each side by negative 10. So that divides out to be 1. So this is going to be the absolute value of 9 plus r is equal to positive 10. I stop right here because I just want to make sure that my absolute value is equal to a positive number. Because if it's not, then we have another conversation to have. So it is. So I keep solving from there. You have either negative 9 plus r is equal to positive 10, or you solve because what's inside here. Don't use your absolute value. The absolute value you lose when you solve it twice. You're just taking what's in the inside here, taking it out. Negative 9 plus r is equal to negative 10. I add 9 to each side. R is equal to 19 here. I add 9 to each side. R is equal to negative 1. Okay, this is not an occasion where you're going to have extraneous solutions. You can do a check. I'll just do a quick check on this right here, just in the top here. So if r is 19, so I'd say negative 10 times negative 9 plus 19 minus 5 is equal to negative 105. Okay, so negative 10 times, and then this is going to be 10 minus 5 equals negative 105. Negative 10 times 10 minus 5 is equal to negative 105. Negative 100 minus 5 equals negative 105. Negative 105 equals negative 105. Now this, when you solve regular equations where there's no variable on this side, there's no x's or anything, those are just going to be your solutions. They're not going to be extraneous solutions with these, just because of the way that we solve it. Okay, I'm going to just do this last check just to show you how you do a check to make sure you have the right answer if you do have time. This is negative 9 minus 1, okay, minus 5 is equal to negative 105. And you can always fast forward through this. Negative 10 times negative 10 minus 5 is equal to negative 105. Negative 10 times positive 10 minus 5 is equal to 105. Negative 100 minus 5 equals negative 105. Negative 105 equals negative 105. And that checks out. So you can do a check if you have time. That would be like the last thing I would do on your test. So, and that's how you do a check. You just always plug it in, always to the original problem. So not here. Okay, always go up to the original problem and do your check. Okay, next one, so negative x minus 4 divided by 9 is equal to 3. Okay, I don't have any addition or subtraction to undo, so I multiply. I get rid of my 9 here by multiplying each side by 9. So this is the absolute value of negative x minus 4 is equal to 27. I stop here and I say to myself, is it equal to a positive? If it's equal to a positive, then I do solve it twice, and that's a positive 27. It's what's out here is the issue. I take what's inside my absolute value, and I take that out, and I solve this twice, because what's in here could be equal to positive 27, and that's going to give me 27, or what's in here could be equal to negative 27, and I would still get positive 27. So I add 4. Negative x is equal to 31. Now this is a negative 1x, so I'm going to divide each side by negative 1. X is equal to negative 31. Add 4, add 4. Negative 1x is equal to negative 23. Divide by negative 1. X is equal to 23. And I didn't do this before, but you're going to have to put your solutions in your brackets. So it's going to be, in this case, it's x. You can do x is equal to, if you don't have that, formative will still accept it. X is equal to And then we have our fancy brackets, x is equal to, and we always go from least to greatest. It will mark you off if you don't go least to greatest, negative 31, and then 23. Okay, so that's up. So let's go and do the next one. So the next one, I'm going to switch to purple just because it's fun. 1 minus 2 times negative 3v minus 10 is equal to 45. Okay, so one of the biggest mistakes is you guys like to combine these. You cannot combine those terms because they're not like terms. This is multiplication. First thing I want to do is I want to get rid of this 1, okay? Because this is addition subtraction. It's just on the other side. So again, this problem here is the same as if I did negative 2 times negative 3v minus 10 plus 1 is equal to 45. These are the exact same thing, okay? But my 1 just happens to be on the other side, just to confuse you a bit. So I bring down, now just be careful with this, I'm going to bring down my negative 2. So this is negative 3v minus 10 is equal to 44. I divide by negative 2, I divide by negative 2. Now my absolute value, I'm getting it by itself and I have to think about something. This is equal to negative 22. I stop here, I always stop here when I have my absolute value by myself and I'm like, is that possible? Okay, because an absolute value, whatever this is, always represents a positive number. Can a positive number, whatever it is, be equal to a negative number? Can a positive number be equal to negative 22? No, there's no way that a positive number could be equal to negative 22. So we are going to write no solutions. Okay, this is a no solutions, or you can do the fancy brackets. If you don't want to write no solutions, you can do the empty set brackets. And you can have a space there or not have a space there, but those are your two answers, no solutions, or you can have your empty set. Informative, we don't have the, this is the other thing, but we don't have that. I don't think that we have that key informative. Okay. Number 4, this is the one where you have to do extraneous solutions. And the difference between number 3 and number 4, the ones we've been doing, is that we have an x on each side. We have an x inside the absolute value, and we have an x outside the absolute value. The procedure is still the same. You still look and get everything out. You isolate your absolute values to make sure everything's there's nothing else on the outside. Then you solve this twice. So now I have my absolute value by itself. I don't have to worry about positives and negatives because I have this x here. So that's not one of my concerns here. I just know that I'm going to have to go through and solve this twice. So this is going to be 2x plus 5. So I take what's inside the absolute value. I keep everything the same, is equal to 3x plus 4. Okay, and I keep the other side the same. Then I do the same thing here. 2x plus 5, don't change that at all, is equal to negative 3x. So again, I make both parts opposite. Negative 3x instead of plus 4 is going to be minus 4. And I go through and solve like normal. So for this, I can either subtract 3x or subtract 2x. I'm going to subtract 2x. So it's going to be x plus 4. I'm going to subtract 4. X is equal to 1. That's one possible answer. Okay. For the next one, I'm going to add 3x to each side because I like adding better than subtracting. It doesn't matter which way you do it, you will get the same answer. If you don't, then you probably did something wrong. Okay, I subtract 5. Subtract 5. I have 5x is equal to negative 9. Divide by 5. Divide by 5. X is equal to negative 9/5. Okay. You also have x could be equal to negative 1 4/5 or negative 1.8. All of those things are acceptable. Okay. So there are a couple things. This is the one where you have to check for extraneous solutions. I'm going to do this algebraically, but I'll show you how to do it in Desmos. I just have to pop up the Desmos calculator. Okay, so I'm going to check to see if this one is an actual solution to this equation. So what I'm going to do is so I have 2x plus the absolute value of 2x plus 5 is equal to 3x plus 4. So I write down the original problem and I replace my x's with everything that's there. So this is going to be 2 times 1 plus 5 is equal to 3 times 1 plus 4. Okay, 2 times 1 is 2 plus 5, absolute value, is equal to 3 plus 4. The absolute value of 7 is equal to 7. 7 is equal to 7. So I know that that checks out. I'm going to put a little check next to it. I know that this is a solution. I'll even circle it. Okay. With the second one, if you don't like to deal with fractions, because if I actually had to substitute this in, I'm just going to put the fraction in, but it doesn't really matter what you put in. It's going to be the absolute value of 2 times negative 9/5 plus 5, absolute value, is equal to 3 times negative 9/5 plus 4. Okay, so it's going to be kind of nasty. If you don't want to deal with that, you can go to, and remember, that's one of the things, you can go to your Desmos scientific calculator, and you can have that popped up. And so what you do is you put the problem in. So I'm going to go back to this. I know it's going to be the absolute value of 2 times negative 9/5 plus 5. So the first side is going to be, all right, the absolute value of 2 times negative 9/5. Ooh, just back that up. 9/5. I just have to look back. 9/5 plus 5. Okay, so you do plus 5, and I get 8.6, so I'm going to press enter. Okay, and then the next one I plug in is I do 3 times negative 9/5 plus 4. So I do 3 times negative 9/5. Ooh, I keep doing that. Negative 9/5. Okay, and then we do plus 4. And so I look, and when I substitute that negative 9/5 in, I ended up with 8.6 for the one side and negative 1.4 for the other side. And so if I was asking you to do this on a test, and I was asking for the check, just put those numbers in. So negative 8.6 and negative 1.4. So 8.6, 0.6, and then you have negative 1.4. You know that those are not equal, so this right here is not a solution. This is what we call an extraneous. It's extra. When we solve, it comes up as a solution. So, but it's actually not a real solution. And so the only thing that I'm going to put in for my answer, and I'll actually make sure that this is pulled up, is x is equal to, and here we go, x is equal to 1. Okay, that was the only one that's a solution. You don't put the extraneous solution because it's not an answer. It's not the correct answer. One other thing that you could do is you could also use graphing. It's the absolute value of 2x plus 5. So I'll show you. Let's go with, we'll go Desmos. We'll go to the graphing calculator. So you could also put this in the absolute value of 2x plus 5, and I'm just going to do this only for this problem, and then it was negative 3x. Ooh. Was it negative 3x? It was, no, it was 3x. My other side was 3x plus 4, I believe. And there's only one spot where they intersect, which is at 1, 7. And we know that 1 was one of our solutions. So that's one of the other ways, is you could graph each side and then see where they intersected. But we're asking you to do this algebraically, so you can only use this for a check. You can't use Desmos. So, but that's just a nice little check if you have that. Otherwise, hopefully I didn't confuse you. All right, so it says choose all of the solutions you have, show your work. So I'm going to just go through this one. Change the color. Let's go to purple. Okay. So 4 times 3 minus x is equal to 8x plus 16. First thing I want to do with this is I need to divide everything by 4 because I want to get my absolute value by itself. So this is going to be 3 minus x is equal to 2x plus 4. Now I'm ready to solve twice. It's going to be 3 minus x is equal to positive 2x plus 4. Again, you always keep what's in the absolute value the same. 3 minus x is equal to negative 2x minus 4. For this, I'm going to add x to each side. So this is going to be 3 is equal to 3x plus 4. I'm going to subtract 4. 3x is equal to negative 1. Divide by 3, divide by 3. X is equal to negative 1/3. That's a possible solution. Okay, the other side, go through the same thing. I'm going to add x, or I'll add x again. Okay, so I'm going to add x. It's going to be 3 is equal to negative 1x minus 4 plus 4 plus 4. 7 is equal to negative 1x. Divide by negative 1, divide by negative 1. X is equal to negative 7. Now remember, both of those answers are there, but what this is kind of tricking you with is you have to make sure that both of those are solutions. So you can do one of the two things. You can go through, plug it into the original problem on your own, okay? Or you can use Desmos. In this case, I'll probably use Desmos just for space, but I'm going to just show you what I want to see as a check. So this would be 4 times the absolute value of 3 minus negative 1/3 is equal to 8 times negative 1/3 plus 16. I'm sorry that's okay, plus 16. So what I'm doing is I'm just going through and plugging it in, okay? But if you're using Desmos, the calculator, we can just go through and just do it this way. So it's 4 absolute value of 3 minus negative 1 over 3. And I get 13.3 repeating, okay? I go plug in the other side, so that's going to be 8 times negative 1/3 plus 16. 8 times negative 1/3 plus 16. Oh no, this is minus. This should be, sorry about that. That's going to be, okay, yeah, so 8 times negative 1/3 plus 16, I end up with the same answer, which is 13.3 repeating. So I know that I'm going to have 13.3 repeating on one side is equal to 13.3 repeating on the other side. So therefore, I know negative 1/3 is a solution. I do the same thing. I'm just going to do this by hand with 7. So this is 4 times the absolute value of 3 minus negative 7. Is equal to 8 times negative 7 plus 16. 4 times 10 is equal to negative 56 plus 16. 4 times 10, because the absolute value of 10 is 10, sorry, my pen has just stopped working, is equal to negative 40. Is positive 40 equal to negative 40? No, so I'm not going to check off negative 7. That is not one of the solutions. So the only thing that you're going to check is that negative 1/3. And again, you can use Desmos for this one too. I just want to remind you that you can do the hand calculation or you can put it in Desmos, but just make sure that you're showing your check. You plugged it in, this is what you got. Okay, number 6. It says the following equation was solved incorrectly. Following equation was solved incorrectly. First, choose the step that has the error, then solve the problem correctly and show your work. Okay, so I'm looking through here and I already see the first problem. The first problem is they did 10 plus 10 and they ended up with the 20 there. But you can't combine your like terms like that, or you can't combine those because they are not like terms. I misspoke. So what you need to do is we need to just go through and correct it. So it was in step A. A was the issue. They combined like terms when they weren't supposed to. So 10 plus 10 absolute value. Okay. And I will fix this in post because there's something, there's an issue here because it would be really helpful for you to actually have that. All right, so give me just a second. I apologize for that. Right. There we are. Okay, let me just refresh. I know you guys didn't need that in this. I just want to make sure so you know what I'm talking about. Okay, hopefully you're fast forwarding. Here we go. I just wanted to make sure that you guys could draw on this. So we have our 10 and our 10 here. Well, you can't, that's not going to be 20. Okay, so we're going to choose it. Step A, that was the issue. That was the one where you guys, that was where the mistake is. So you go through and you solve. I'll make sure that this is moved over. So I have the 10 plus 10. So I have 10 plus 10, absolute value of 10x plus 4 equals 80. I'm going to subtract 10 first. So this is going to be 10 times the absolute value of 10x plus 4 is equal to 70. Divide by 10, divide by 10. Absolute value of 10x plus 4 is equal to 7. And then I make sure I solve it twice. So this is going to be 10x plus 4 is equal to 7. Subtract 4, 10x is equal to 3. Divide by 10, divide by 10. X is equal to 3/10. And then we have 10x plus 4 is equal to negative 7, minus 4, minus 4. 10x is equal to negative 11. Divide by 10, divide by 10. X is equal to negative 11/10. So that's it solved correctly, but your answer was right in A. A was the biggest issue. So, all right. Let's go to number 7. So I have to actually fix the spelling of equation. The following equation was solved incorrectly. Determine which steps were made and explain the error. For this here, they divided by -2, so the error is in step A. They divided, so you'd say A in your answers. Hopefully yours is actually coming out. And you would write, they divided by -2 rather than adding 2. Okay, I'm going to refresh because I am having lots of technical difficulties today. Hopefully my answer is there. Formative is usually pretty good, even if it doesn't show up. Yep, A. They divided by -2 rather than adding 2. Okay. So now we're on to inequalities. So home stretch. I know that this is a super long video. I'm actually going to stop right here. So I'll split this up into 2 parts. So that was equations. If you needed help with equations,